morning, dear students. So today we're going to discuss about telescope. We have finished the topic microscope, both simple and compound microscope we have discussed, and I hope you have gone through it and you have practiced it hard. So today's topic you please write down, that is telescope. Telescope, and we'll discuss about two types of telescope in your class 12 standard physics. That is, one is your refracting types, refracting types telescope, and second one is your reflecting types telescope. So these two type of telescope will discuss as per your syllabus of class 12 physics standard is concerned. So we found that what is microscope? Microscope was an optical instrument that is used to see a small object largely. And what will be the telescopes used? Telescope is also an optical instrument that is used to see a far object nearby you in a distinctly. Okay, it is an optical instrument that is used to see a far object near to you distinctly. Okay, that means we use this optical instrument to see an distance object nearly. Okay, that too distinctly. So this is an definitions of telescope. Now we'll go through the refracting types of telescope, and first of all we'll discuss about astronomical telescope. At first we'll go to the astronomical telescope. Astronomical telescope. So what is astronomical telescope now? That in order to see some astronomical objects, like your galaxy, some distant star, to study about some distant planet, all these things, to see closely nearby you distinctly, nearby you, we use astronomical telescope, and it is an refracting types of telescope. You can write down, this is an refracting types telescope, astronomical telescope. Okay, so what we'll do in this case, that in astronomical telescope we will use again two lenses. That means we will use two convex lens. One is slightly bigger and one is smaller. That means the bigger one will be objective lens, and the smaller one will be your eyepiece lens. Let us go for the ray diagram of astronomical telescope. As I mentioned you, that we'll use here two lenses, and suppose this is the bigger lens and this lens is objective lens. This is objective lens. So suppose this is objective lens. Now it will have its principal axis. So this is its principal axis. Now if we consider that if objects comes from infinity, if the object is at infinity and the ray of light comes like that, it will be converged here. That means image will be produced here, we know. But as you know, when you will see some astronomical object like some distant star, some galaxies, all these things, then how we will hold the telescope? We hold the telescope by making some angle with the plane. That means if you consider this is the principal axis, then we will make some angle. That means we will see like that, not straightly. In order to see some astronomical objects, what we do? We hold the telescope by making so that it makes little bit of angle, And if we consider similarly, suppose this is the optical center, this is optical center. If I consider that like that the ray are coming, they're coming from infinite distance so far. This is one more ray, they're coming also from infinity, and at a certain point after refraction they are going to bend like that. Okay, similarly they were also going to bend in this fashion. Okay, so here we get the image. This is the image of the distance object, and this is going to be ADS BDS, and it is going to be a virtual object for you, virtual image. Okay, so object is at now infinite distance. Now this is the object, so object is making an angle alpha. If this angle is alpha, this angle will also become alpha. Is that clear? Now one more lens we'll use to see this image clearly. That means we will use another lens. That lens will be eyepiece lens. This is slightly smaller. This is an eyepiece lens we have used. So this is LE, and this is the optical center of this particular eyepiece lens. Now for this eyepiece lens, image of the objective lens will behave as object. This is as usual thing I have told you so many times, that now this partial image, this object, this image will behave as object for the eyepiece lens. So what will happen then? Let's see. This ray will go like that, and this will go to the principal focus. This ray will go like that. That means what you can see, that these are diagram directions. You don't forget to put the directions. These are essential. This will undeviated, as you know. Now in this case, so where image is forming now? The image is forming at infinite distance, very clearly. Very clearly you can see. Okay? Like that, the image is forming at infinity distance. What happens when the image is formed at infinity? Your eyes does not get any stress. Observer's eye does not feel any stress. So this is simply the ray diagrams of astronomical telescope. That is a refractive type of telescope. That is why we have used a lens. So what you have observed from this diagram, there is objective lens. These are rays coming from the object at infinity. I am considering that this is the angle made by the object. It is alpha. So if it is alpha, this angle will also be alpha. Now again, as you can see, that this image of objective lens will behave as object for the eyepiece lens. This is LE, and so they are making an image. Once you put this eyepiece lens, or once you see this object by using the eyepiece lens, you will see images forming at infinity. Am I clear? So this is the angle formed by the image. Suppose it is beta, and if it is beta, this angle is also going to be beta. Is that clear? So image is forming at infinite distance. Now again, simple thing, we'll follow the magnifying power or angular magnification as we did in microscope. So you know how to find out the angular magnification or magnifying power. So I'm writing here that angular magnification, angular magnification M. How to find the angular magnification M? As you know, that angular magnifications M will be found as angle formed by image divided by angle formed by object. Okay, this is the angular magnifications, and that is angle formed by image and angle formed by object. This is a quite simple phenomenon. So as we found that this is m is equal to, what is that angle formed by image? This is image is forming an angle beta, so I am writing here beta, upon angle formed by object. By the object, angle is formed like that, this is alpha. So m is equal to alpha by beta. Finally we have got. If these angles are too small, okay, if we consider that these angles are too small, then what can we write? If angles are too small, then this beta will become equivalent to tan beta, and alpha will become equivalent to tan alpha. Okay, so like that they will become. So this equation will be m is equal to tan beta by tan alpha. Now you go to find out the tan beta, tan alpha. Let us see what comes. So we can write m is equal to, what is tan alpha? This is alpha, this is alpha. So if I give some name over it, that this alpha we can find from triangle ADS. Okay, and this is your beta. Beta can be found from triangle ADS, right? So from triangle ADS, I will find beta. Tan is equal to perpendicular upon base, so ADS by EB dash. You can write ADS by EB dash. Is it clear? ADS by EB dash, perpendicular upon base for tan beta. Now tan alpha, I am writing in one line. If I multiply, so tan alpha ratio will be reverse. What will be tan alpha exactly? ADS by OADS, or no? ADS by OADS, but as I am telling that I am making this multiplication, so it will be OADS upon ADS. You can write OADS by, you can write OADS by ADS. ADS will be cancelled out, so we can write m is equal to what you have left out, and above it is OADS and below it is EB dash. This implies m is equal to, I can write that what is OADS. I forget to give some value again. I am giving it so that you don't have any particular confusion. Okay, so this will be up to here. That means where this image is forming. So this is the focal length FE. From here to here, this is going to be focal length FE, focal length for objective lens. From here to here, focal length. Since this is image is format, principal focus. And again, this is going to be FE. This is going to be FE. This distance is going to be FE. Okay, focal length for eyepiece lens, and this is also going to be FE. Is that clear? This much is FO, so OADS is FO, and EADS is your FE. So I can write in the place of OADS FO, I'll write FO, and in the place of EBDS, that is EBDS, I'll write FE. So this is the magnifying power, general magnifying power of an astronomical telescope. M is equal to FO upon FE. Is that clear? So M is equal to FO upon FE. That is the general magnifying power for astronomical telescope. But again, there are one possibilities. So if we discuss that things, we have done it very beautifully. If image is formed if image is formed at least distance of distinct vision, if image is formed at least distance of distinct vision, mind it, if image, in this case where image is forming at infinity and the object was placed at focus. That means if the object is at focus, the image will form at infinity. But in this case, where image should be formed at LDDV, least distance of distinct vision. As we did in case of compound microscope, that once we keep the object between optical center and principal focus. Are you getting my point? If you place the object between optical center and principal focus, remember optical center and principal focus, then image will form at least distance of distinct vision. Okay. So in this case, what I should do now? I cannot replace this object, or I cannot adjust this object. I cannot change the position of the object right now. So what I can do, this lens cannot be adjusted, but I can adjust this lens. If I adjust this lens, okay, if I adjust this lens, then what will happen? If I adjust this lens slightly this side, then this object will be placed between optical center and focal length. Are you getting it? Understand? You see very clearly. See, in this case, where the image is now, object is at focus. That is why this is object is at focus. That is why it is focal length Fe, and image forming at infinity. But if I replace this object, or if I keep this object between optical center and focal length, then what will happen? If this object is placed within optical center and focal length, then this, instead of this focal length, this will become object distance, and image will form at some distance, that is somewhere might be this distance of distinct vision. So what I will do for now, I will not rubbing the whole diagram. I am just showing by rubbing this particular point. Okay. I am just adjusting the eyepiece lens. That means I am changing its position. So I am bringing the eyepiece lens close to here. As I bring this eyepiece lens close to here, this object will become inside focal length and optical center. Have you got the point? Distance I have adjust this lens so that I can replace this ball object between optical center and principal focus. That means now this distance will become object distance for UE, object distance for eyepiece lens. Understand? But in this case, image will be forming at some particular distance. That means the image formation will be traceable in this case. Like that will go, and somewhere here they will meet. Here they are meeting, and as you can see, and where they are meeting now, they are meeting suppose at this point, and image is forming here, and this image will become ADS, BDS. This is your optical center for the eyepiece lens. Remember, this is optical center for the eyepiece lens. Have you got the definitions now? And this was remaining as it is. This is Fe. Nothing has changed. As I have changed the positions of the lens, then this object has gone inside optical center of eyepiece and the focal length, so that this distance will be object distance. That thing will be changed. So if I go to find out angular magnification, in this case m will be same only, beta by alpha. But what will be the things that in this case now again? So in this case, what I'll write, that magnifying power m is equal to, it will be similar. What similar? This will be tan beta upon tan alpha, it will remain as it is. But if I go to find out the tan alpha, same triangle, value will also be same. That means what is tan alpha was, tan beta was, this is tan beta, A dash B dash by EB dash. So that is tan alpha will also remain same. See, nothing has changed, only the position has changed. So tan alpha will become your O A dash by A dash B dash. Okay, so I will cancel A dash B dash. What I will have M is equal to O A dash by EB dash. So M is equal to what is O A dash? In this case, O A dash is nothing, this FO. O A dash is FO, and EB dash, once you change this position, that is not EB dash, it is EB or EA. You have written something different, it is EA dash. Okay, so it is not EB dash. What EB dash you have got here? Tan, it is in this tan beta. This is tan beta. A dash B dash upon EA dash. Okay, my apology. So this angle you can say tan beta, na? This is tan beta. So tan beta will be what? This angle is beta. This angle is beta, so this angle will also become beta. So on that case, tan beta was A dash B dash upon EA dash. Sorry, this is EA dash. Okay, so EA dash, on the previous case it was FE. So in the place of EA dash it was FE. Is that clear to you? It is not EB dash, this EA dash. So similar case in this year also. This will remain EA dash. Don't get confused. This is EA dash. This is EA dash. A dash B dash perpendicular, EA dash base. So perpendicular upon base. Clear now? Okay, so don't have any doubt. So in the place of EA dash, what will write distance? UE. This is UE. So this is the magnifying power we have got once the object is at least distance of distinct vision. But in this case, we have to apply the lens formula. Okay, since the image is forming at least distance of distinct vision. If I bring the lens formula here, everyone knows what is lens formula. You write now from lens formula. Now from lens formula. What was lens formula? Lens formula was 1 by f is equal to 1 by f, but this will be for eyepiece, as you are finding this image for eyepiece. It is fe by 1 by pe minus 1 by ue. Now go for sign convention. This 1 by fe is equal to 1 by pe, image distance. Image distance means, as you can see, that this distance, okay, this distance where the image is formed, that is this distance of distinct vision I have considered. That means this distance from here to here, this much of distance is least distance of distinct vision. How we can come to know that I have replaced this object between optical center and principal focus, instead of keeping the focus. So we can see that this distance will be least distance of distinct vision. So this is image distance. Image distance will be here minus d, and this will become object distance is negative. So if I put minus here, it will be minus plus ue. So if I write here 1 by ue is equal to, this will be like that, 1 by fe plus 1 by d. 1 by ue is equal to 1 by fe plus 1 by d. Now, as you can see here, what is this equation? This equation, it is not 1 by, so this is 1 by ue is equal to 1 by fe plus 1 by d. Now, from these equations, you can give some name over. This is suppose number 2 and this is suppose number 1. Okay, now I will write from number 1 equation. From number 1. This is number 1 equation, number 2, from number 2 equation. This is number 2 equation. What I can find from number 2 equation? I can find that m is equal to, I can write FO into 1 by UE. I can write, this is number 2 equation, m is equal to FO by UE. So I can write this is as m is equal to FO into 1 by UE. Clear? FO into 1 by UE. So m is equal to FO in the place of 1 by UE. This is 1 by UE. I can put 1 by FE plus 1 by D. Now we do a simple thing here. We take from here 1 by FE common. That means from these 2 points we will take 1 by FE common. So this will become, if I take 1 by, this is FO, I am taking 1 by FE common. This is 1 plus FE by D. Or I can write that m is equal to FO by FE into 1 plus FE by D. And this is the magnifying power or angular magnification for compound astronomical telescope when the object is at this distance of distinguisher. I hope you have cleared, except there's some a little bit of problem happened. This I have rechanged it. No need to worry about it, just go through it and practice it. If any doubt, just inbox me. I'll try to clear once again if you did it so. Okay, thank you so much.